Okay, so we are actually back to our managerial economics tutorial section. Okay, so today I'm going to solve the tutorial questions. So with the first question that was given was based on demand estimation, which is our question 1. So now with demand estimation, we've been provided with an estimated function 240 minus 2px plus 0.4 pz plus 0.08y. We have this into bracket. The ones in parentheses, these particular ones, are called the standard errors. It was given in the question. I'll make sure to attach the question to the video so that you can get access to them. So with r squared, it was given as 0.850. We have disposable income, y, given as 1,000. We have px, price of Papa's pizza. We were not given any value for that. We have pz, price of Eddie's pizza. We were given 100. So the first part of the question, the I, is saying that let's interpret the coefficients of the independent variables. So now one would ask, which ones are the independent variables? This is what we do. When you come to this estimated function, the variables here, we have px, we have pz, we have y. With these variables, we call them the independent variables or the regressors. So one would still ask, so which one is the coefficients then? The coefficients are the numbers that are attached to the variables. So meaning that the coefficient of px is minus 2. The coefficient of pz is what? Positive 0.4. The coefficient of y, which is income, is what? 0.08y. And we've been asked to interpret the coefficient of what? The independent variable. So I'll pick the first one, px. So this is px. So px, it was minus 2. So this is how we interpret it. A unit increase in the dependent variable. In the dependent variable. So the dependent variable is the QS here, this particular one. QS will lead to a decrease in px by 2 units. All things being equal. So now let me explain how to go about it. With px, we were given minus 2. So we are saying a unit increase. We always start with this condition, a unit increase. So a unit increase in the dependent variable, which is the QS, will lead to a decrease. So one would ask, why are we using increase and using a decrease here? We are using a decrease because then sign here is negative. If it's negative, we use decrease. If it's positive, we use increase. So since it's negative, a unit increase in the dependent variable, QS, will lead to a decrease in px. It's negative, so a decrease in px. By, you pick the number here, you add units. So take note of this side, this particular side. So will lead to a decrease in px by 2 units. Then you add this, all things being equal. So that's how we interpret the px. So we'll move to the next variable, which is pz. So this is pz. Pz was 0.4. So we start a unit increase in pz. So a unit increase in the dependent variable. Which is the QS, will lead to, this is positive, so to an increase. So an increase in pz by 0.4 units. Then you add all things being equal. So the next variable we have in the equation is y. So I'll pick y. This is y. This is 0.08. So a unit increase in the dependent variable, which is the QS, will lead to, it's positive, so to an increase in Y by then 0.08, you add units, all things being equal. So that is how we basically interpret the coefficient of the independent variable. So they are the numbers that are attached to each variable in the equation. So the coefficient of px is -2. So one would also ask, okay, so say, what if they don't state coefficients in the question? How then do we get them? Another name for coefficient is parameter estimates. So in case you don't see coefficients in the question, it's the same as parameter estimate. Yes. So that is how we solve the first part of the question, which is the I. So you move to the second one. So the II. So the second part of the question is saying that what are the significance determinants of quantity demanded? What are the significant determinants of quantity demanded? Like this, explain. So that was the second question given. What are the significant determinants of quantity demanded? Now, whenever you are asked to find the significant determinants of quantity demanded, that is where the concept of hypothesis testing comes in mind. Now, when you are finding for the significance of the determinants of quantity demanded, we have two approaches we use. Now, take note that there's a first and our hypothesis testing. So, with the two approaches, either we use the p-value concept, p-value, against the level of significance, or we use the t-cal or the t-stat. The t-cal is called the t-calculated. T-stat is t-statistics. So we pick the absolute values of t-cal or t-stat against our t-tab, what we call the t-tabulated or t-critical. So these are the two approaches we use in finding the significance determinants of quantity demanded. Either you use the p-value against the level of significance concept, or you use the absolute values of t-cal or t-statistics against the t-tab or t-critical. So let's move back to the question and choose the one we are going to use. So when we check this particular question, there's nothing like p-values or level of significance in the question. So meaning that if I'm finding for the significance determinants of quantity demanded here, with this particular concept, this one, it wouldn't work for this particular question. So which one do we use? So meaning that once this particular one is not working, meaning that the second approach is what? Going to work. So with this particular question, there's the concept we are going to use to solve the II part of the question. We are going to use the absolute values of t-cal and t-stat against our t-tab or t-critical in the question. So I'll clean the side and solve the question. So as I stated earlier on that, we are going to use the t-cal or the t-tab concept against the t-critical. So this is what we do. So let me do it step 1. With the step 1, I find my absolute values of t-cal or t-stat. So t-cal is t-critical, t-stat is t-statistics. So the formula is coefficient Either your coefficient or parameter estimate is the same thing. So in case you are not giving coefficient in the question, you see parameter estimate. So coefficient or parameter estimate divided by our standard error. That's the formula we use. So what we'll do is we will pick each of the independent variables. The independent QS dependent variable. Any variables across the equal to sign are considered as the independent variables. So the independent variables here are px, pz, y. So those are the variables we are finding the significance of. So I'll first pick my px. This is px. The formula is coefficient or parameters over standard error. So I'll come to the px side of the question. How do I get a coefficient? Remember that in the question it was stated that the values in parentheses are our standard error. So we already know of the standard error. So now we are coming to the coefficient. So know that we are starting with px. So the coefficient of px is what? -2. So right beneath it, we have a standard error of 0.68. So meaning that with the px, coefficient is -2. This is 0.68. Then we have the next one to be pz. We have 0.4 over the number beneath 0.1. Then we have the next one, it's y. Y is 0.08 divided by the standard error beneath 0.025. So we are going to find the answers for this particular side. Cut it. We have the absolute values of t cal and t stat. So coefficient or parameter is divided by our standard error. So we have px -2 divided by 0.68, pz 0.4 divided by 0.1, y is 0.08 divided by 0.025. So we'll use the calculator. So the first one, -2 divided by 0.68. We are having -2.94. But take note, per the formula is saying that the absolute values. So why do we bring absolute values? We want to eliminate the negatives. So this is negative, so absolute value. So our final answer is now 2.94, not negative 2.94. So the next one is 0.4 divided by 0.1, which is giving us 4. This one is 0.08 divided by 0.025. I have 3.2. So we are done with the step 1. So with the step 2, we need the t tab or the t critical. Now, with this particular question, they didn't state anything like t critical or t tab. Now, since we are finding for significance of the determinant, and this is the concept we are using, for us to get the t tab or the t critical, since it's not stated, we have a way we calculate for the t tab or the t critical. But since it's not given here, we assume a thumb rule of 2. So meaning that with the t tab or the t critical, we are going to use 2. That's the assumption. If it's not given, we assume a thumb rule of 2. So I'll clean the side. So we finally create a table for it. There's our variables. There's our variables. We had px, pz, and py. So with this side, I'll put my t cal, either the t cal or the t stat. I'll put it here. So the t cal for px is 2.94. This is 2.94. Pz is 4. So we have 4 here. Py is 2. Sorry, py, the y, sorry, not py, y. Y is 3.2. So this is 3.2. Then the next column is where I'll put the T tab or the T critical. So let me put it here. T tab or the T critical, like this. So remember this side, we assumed we're not given, so we assume 2. So you fill it throughout. So 2, 2, 2. So we have what we call the decision rule. So the decision rule would help us to know which of the variables are statistically significant. So this is what we do. If the absolute values of your T cal or your T stat is greater than your T tab or your T critical, then it's significant. But if the absolute values of your T cal or the T stat is lesser than the T tab or the T critical, which is 2, then it becomes not significant. People say insignificant, but the right English is not significant. So let's start. So 2.94. So now pick the first variable, px. So 2.94 is greater than this. So 2.94 is greater than 2. Therefore, it's significant. So meaning that the variable px is what? Significant. That's how we do it. So the next one is pz. So with pz, 4 is greater than this. So 4 is greater than 2. So it's also significant. Then we have the next one, py. Py is 3.2. It's also greater than 2, which is also significant. So we make a conclusion for it. So there's the conclusion. Now, so px is significant, pz is also significant, py is also what? Significant. And they are saying that what are the significance determinants of quantity demanded? Since you are getting all the variables to be significant, meaning that all the variables given in the question, which are px, pz, and py, are what? Statistically what? Significant. That's all for the second part of the question. So let me clean this side. So we move on to the third part of the question. The third part of the question is saying that state the law of demand and explain how the estimated demand equation, which is this, confirms or rejects the law of demand. State the law of demand. So state the law of demand. And explain whether the estimated demand equation confirms or rejects the law of demand. So we are saying that state the law of demand and explain whether the estimated demand equation, which is this, confirms or rejects the law of demand. So I'll start with the law of demand first. So the law of demand states that the higher the price, the lower the quantity demanded. the quantity demanded. And also, the lower the price, the higher the quantity demanded. So that is what we refer to as the law of demand. But when you're asked to explain the law of demand, then you just do only this. You can be marked down because it has a condition attached to it. Once you are done with this, we continue by saying that ceteris paribus. So the ceteris paribus states that all things being equal, so that's the law of demand. And now that same question was asked to show whether this estimated demand equation confirms what? The law of demand. So that's what we do. For you to know whether it confirms the law of demand, that's what we do. Take note, this is scale S. So after the equal to, when we see any price here, which also has Px, then meaning that becomes the actual price of this scale S. Why am I saying that? This is quantity demanded of X. So if you are able to get price of X here, then meaning that is the own price of this quantity. So one would ask, but there's also PZ there. So why not PZ but PX? It's not PZ because this is PZ, this is scale S. Z and X are not the same. So meaning that what this PX is the related product of what? X. But once what? The actual commodity in question. So the actual commodity in question is KOS, which is X. So quantity demanded or quantity of commodity X and price of that same commodity. So for us to know whether it confirms the law of demand, that's what we do. This side is negative. This side is what? KOS. So we have a simple way to do it. Now take note. This is PX, this is PZ. But we need the price for this X. So we pick this particular one. Now since it's negative, meaning that it confirms the law of demand. Why am I saying that? With demand, it shows an inverse relationship between quantity of the same commodity and price of that same commodity. Or it confirms the law of demand because there is a negative relationship between price of good X and quantity of what? Good X. That's how we do it. So assuming this side was positive, we would reject it because it doesn't confirm what? The law of demand. For the law of demand, for it to confirm the law of demand, you need to have an inverse relationship or a negative relationship. And it's negative, so it confirms it. So assuming it was positive, it doesn't confirm the law of demand. So we have, so we do it this way. So it confirms the law of demand because it has an inverse relationship. An inverse relationship between quantity demanded of good X and price of that same product, which is the PX. So it's either you use this one or you say that it has a negative relationship between quantity demanded of what? Good X and price of that same commodity. We have a different way you can also confirm it. You look for the variables PZ and Y. We were given numbers for it. You substitute it into the equation, then get what? A demand function. You still have it to be negative, but you just go strictly by this particular format, that's all. So you move to the next one, which is the IV. So the I vein is saying that find an expression for quantity demanded in terms of price. Expression for quantity demanded in terms of price. So there's the question. Find an expression for quantity demanded in terms of price. So for us to get the expression for quantity demand or quantity demanded, we'll pick this estimated demand equation. We're given, so estimated demand equation. So it was giving us QoS is equal to 240 minus 2px plus 0.4 pz plus 0.08y. So for us to get the expression for quantity demanded, we will check the question. If we were provided numbers for the various variables, then we substitute them into what the equation. So the final equation we get becomes what the expression for what quantity demanded. So we'll check from this side. With px, we were not given any value. With pz, it was given as 100. Then we have y given as 1000. So we come to this side. So pz was 100 and y was given as 1000. So we have QoS here. This is 240 minus 2px plus 0.4. pz was given as 100 plus 0.08. Y was given as 1000. So we use the calculator. 0.4 times 100 is given as 40. So we have QoS to be here. This is 240 minus 2px plus this is 40. So we'll try the next one. 0.08 times 1000 would give us 80. So plus 80. So the next thing we'll do is we have numbers here, so we add them up. So this is 240 plus 40 plus 80. This gives us 360. So we have QoS to be 360 minus 2px. So this becomes the expression for quantity demanded. So this is the expression for quantity what demanded. QoS is equal to 360 minus 2px. But take note, that same question, you are saying that find the expression for quantity demanded in terms of price. So what we'll do is you will pick the same equation and make px the subject. That becomes what? What the question is asking you for. They are saying find the expression for quantity demanded in terms of price. So this is quantity demanded. So we want it in terms of price. So let me do it here for you to follow up. So this is in terms of price. Okay. So as I was saying, find the expression for quantity demanded in terms of price. That's what we have. We'll pick the estimated demand equation. Then we'll substitute what the values into it. So this becomes our expression for quantity demanded. But they are saying that in terms of what? Price. So we'll pick this same equation and make PL the subject. So this is QoS. This is 360 minus 2px. So you are making PL the subject. It's negative 2px. You move it. Positive 2px. This is 360. You move this one, becoming minus qx. So we have 2px. We divide both sides by the coefficient of px, which is 2. So this is 2. We have this. This is 360 over 2. This is qx over 2. We move this. So we have px equal to, so we'll go here, go into this 180. So px is 180 minus. Remember that with this variable qs, there's always 1 attached to it. So 1 divided by 2 will give you 0.5. Remember it's what? QoS. So this is the price function. So you are saying that find an expression for quantity demanded in terms of price. So this is quantity demanded expression. This is what in terms of price. So the very part of the question is saying that using the demand equation in Ivan. This was the demand equation in Ivan. Using this in Ivan. Find the price. That will find the price and quantity. That will maximize the firm's sales revenue. So take note, we have what? Sales revenue here. So we are going to use the total revenue to find for price and quantity. So this is total revenue. So total revenue, it's price times quantity. So always the Q here is constant. Most mistakes people do is, since we have QX is equal to this, they rather come and fix this particular equation here and multiply it by P. No, we don't do it that way. What we do is QX is always constant. So you are supposed to find for the price or the price function in the question. Then you multiply with what? The Q. So when we check from this side, remember that we made Px the subject. So we will pick this equation to where the price is. So this side. So we have 180 minus 0.5 Q. Remember that it was QL, but since this one is Q, so I'm making this one just a Q. It's the same thing. So I open brackets. Remember there's a Q here. This is it. So I expand it. So Q times 180 will give me 180 Q. Negative 0.5 Q times Q will give me negative 0.5 Q squared. So this is my total revenue function. Let me clean. Now, we are saying that we should find the price and quantity demand that will maximize the firm's sales revenue. So now we have the sales revenue here, or the total revenue. So with this total revenue would help us to get the quantity. Are you okay? Once we have the quantity, we already know the price function. We substitute the value of the Q, which is the quantity, into the what? Price function, then we get what the price, that's it. So I'll pick this total revenue function, this particular one. So this is T here. This is 180 Q minus 0.5 Q squared. Since we are finding for Q, which is quantity in this particular equation, how then do we do it? This is what we do. We have what we call the first order condition, the second order condition. Or the simple way we do it, we find the derivative. That is what we call derivative, the turning 6, or what we call the sleeping 6. Then the D is called differentiate. We get same answers, but that is what we use, the derivative. So I find the derivative of total revenue with respect to Q. I'm finding derivative of this total revenue with respect to what? Quantity. So I repeat, this is 180 Q minus 0.5 Q squared. I'm finding it with respect to Q. So this is 180 Q. We are finding total revenue, the derivative of total revenue with respect to the derivative of Q. And this is 180 Q. Now take note, it already has an exponent of 1. We subtract 1 from it, it becomes Q exponent 0. And Q exponent 0 is what? 1. So 180 times 1 becomes what? 180. Or the simple trick is, we are finding this in terms of Q. So this is Q, it just moves out. Or you use the other concept. So minus, now in terms of indices, when a variable already have an exponent, we bring the exponent in front of the number. So it becomes, you bring the 2 in front of the number, so it becomes 2. So bracket 0.5 Q, like this. Remember that with the 2, we subtract 1. Once you bring the number in front of the, once you bring the 2 in front of this number, which is this, remember that with the exponent, we now subtract 1 from it. That's the rule based on indices. So 2 times 0.5 would give us 1. So we have 180 minus Q. Now, when we subtract 1 from 2, we are getting what? 1. But we don't have Q exponent 1. So since we have this, and we are finding for Q, we equate this equation to 0 like this. So meaning I have 180 minus Q is equal to 0. So I make Q the subject. So this is 180. I move this equal to Q. So meaning quantity is 180. Now we want to find, they said price and quantity. So this is quantity. We want what? Price. So I'll just pick the price function. So with the price function, PS was giving us 180 minus 0.5 Q. So we now have the Q to be 180. So PX is equal to, this is 180 minus 0.5. Remember, the Q here is 180. So this is 180. So PX is equal to, this is 180 minus 0.5 times 180. 0.5 times 180 will give us 90. So we have this 90 here. So when we subtract 90 from 180, it gives us 90. So meaning that with the feed part of the question, we are asked using the demand equation in Ivan, find the price and quantity. That will maximize the firm sales revenue. So this is the quantity and this is what? The price. So this is how we solve the Venn part of the question. So we move on to the last part of this question, which is the Venn I part of the question. It's saying that labor expects employers to increase income disposable by 20% in the next year. How will this increase in consumers' disposable income affect the quantity demanded? So the last one, labor expects employers to increase income. So the Venn part, increase income by 20%. Labor expects employers to increase income by 20% in the next year. How will this increase consumers' disposable income? How will this increase in consumers' disposable income affect the quantity demanded? So how will this increase in consumers' disposable affect quantity So the last part of the question is saying that if consumers' income increases by 20%, how will this increase in consumers' disposable affect quantity demanded? So when you are given such questions, what comes in mind as what? Income. They're talking about income. So how then do we know the increase in income, which is the 20%? So we're given an increase in income of 20%. And the final question is saying that how will this increase, which is the 20%, in consumer disposable affect quantity what? Demanded. So meaning that with the last part of the question, since we are given income here, we are going to solve for elasticity of income like that. Or income elasticity. So with income, we use capital Y. We use I or capital M. This is what we use to denote income. But in the question, it was stated that we should use Y for what? Disposable income. But the actual variables we use for income are capital I and capital Y. Capital I and capital M. But in the question, we were restricted that we should use the Y in this question for what? Disposable income. So I have this. So Y. So the proportionate change in QoS over proportionate change in what? Y. Because that's what we are dealing with. So we find the derivative of QoS. We express the derivative of Y. We open bracket. This is Y over QS. So this is the expansion form. So we are finding for income elasticity. So we are finding the derivative of QS with respect to what? The derivative of y. So now with this y, it was already given in the question. It was given us 1,000. So we know y, 1,000. Now with the QS is what we have already solved in the previous question as what? 180. So now we are left with just the side to solve for what? The income elasticity. So how then do we get this? If you want to get this particular answer for this side, you will pick this estimated demand equation. We were given QS. This is 240 minus 2px plus 0.4 pz plus 0.08y. We are saying that we are finding the derivative of this QS with respect to the derivative of y. So what we will do is, you come and look for this variable y in this equation. So this is it. Then the next thing we'll do is, you pick the coefficient, or you pick the number which is attached to the y. What number is it? 0.08. So meaning that the whole of this side is 0.08. That's all. So we have 0.08 like this. Y was 1,000. This side is 180. So income elasticity, let's use the calculator. 0.08 times 1,000 divided by 180 is giving us 0.44. So this is 0.44. And remember, per their interpretation, this is income. If it's positive, then it's a normal good. We weren't asked though, but in case you're asked to interpret, if it's positive, it's a normal good. If it's negative, then it's an inferior good. So now, this is what we are getting for the income elasticity. But they are saying that, what if this, the answer we are getting here, what if this income elasticity increases by what? 20%. How is it going to affect quantity demanded? So what we'll do is, we will come back to the first equation, which is this particular one. So I'm making an arrow to it. So I'm bringing it to this side. So this is income elasticity. This is proportionate, or what people say percentage, but I think it's proportionate. This is QS. This is changing Y. Okay, so with this EY here, with this one, the EY, income elasticity, is what we've solved here as what? 0.44. So I'll bring it to this side, 0.44. So in the question, were we given anything like proportionate change in QS? No, we don't have anything like that in the question. So I bring it back like this. But do we have anything like proportionate change in Y? Yes, in the question, as I said earlier on, people use percentages in expressions as percentage change in QS. It's the same thing as proportionate change in QS. So when we come back to the question, we're given an increase in percentage. They are saying that income increases by what? 20%. So meaning that what that side, the percentage change in income was given as 20%. 20%. So increase in income was given as 20%, which is 0.2. So let me just fix it straight here. 0.2. You convert this. Now, we have nothing, we divide by 1, we cross multiply. So we have proportionate change in the QS here. That is 0.44 times 0.2. So we have this. So we have 0.44 times 0.2. We are having 0.008, 0.088. Now, but we are saying that, how will this increase in consumers' income, which is the 20%, affect quantity what? Demanded. So take note. This is 0.088. But take note that what that side we have what? A percentage change in QS, a proportionate change in QS. So we are supposed to find for this quantity in terms of what? Percentage. So what we do is we bring back this QS because of the percentage here. We multiply this final answer by 100. So 0.088 times 100 is giving us 8.8. 8.8%. So meaning that if we increase income by 20%, it's going to affect quantity demanded by what? 8.8%. That's how we solve this particular question. So as I explained earlier on, this particular question is a demand estimation question. So we will try and tackle all the tutorial questions. But for now, this is what we mean by the demand estimation. So I would say thank you all for watching our managerial economics tutorial videos, and we beg you guys to keep sharing to your friends in other institutions to also help them grab the concept of demand estimation. I thank you all and I love you all. So we will still continue with the videos. Thank you.